All right, in today's lesson, we are going to be graphing circles and writing their equations. So previously we've been talking about circles in a plane, just the relationships between angles and polygons and other things related to those circles and their arcs. Today we're going to give it some concrete direction as far as putting it onto a coordinate grid. So the learning target, students will be able to write the equation for and draw the graph of a circle. We want to be able to go forward with whatever information we're given to do that, as well as if we were given a graph, could we go backwards and write the equation or identify different parts of the circle. Just becoming comfortable with all of those different pieces. So first of all, a circle is a set of all points, we already kind of talked about this, that are equidistant from a given point called the center. This makes them pretty easy to graph. Hard to draw, but easy to find where their graph should go. So basically, if we have a center, we can put it anywhere on the graph, wherever it tells us that the center is, and then the radius, right, is just all the points around that. So if we know a center and we know that the radius is a certain length, then we can build our circle all the way around there, creating a circle with those equidistant points. So the equation of a circle, what does it look like? Well, it says we can derive the equation of a circle using Pythagorean theorem or the distance formula. I'm going to look at it in the Pythagorean theorem way. So notice here we just have a circle, arbitrary circle graphed where its center is at the origin. This makes it easy to kind of look at the first equation of a circle. Notice all these points, right, are r distance away. Our radius is length r. R just stands for any arbitrary length. And it's moving out to a point x, y. So that means it's gone over this many units x. We would count it up this many units y, right? Circles are awesome if we can create little triangles like this because we can talk about their points, and we'll do more so in the future. When you're looking at this, then, if I were to represent that, I don't know why I wrote a 4. That should be a y. So if we're looking at this right here, again, remember that the Pythagorean theorem is just legs squared plus legs squared, and that's equal to whatever the hypotenuse of the right triangle is. There's our right angle right here, which means this is the hypotenuse, right? So that's like x squared plus y squared equals r squared. This is the equation of a circle if the circle is centered at the origin. R squared, notice, is always this value right here. So we can find the radius length or use the radius length to build the equation, and then this relates to the center. Now if we move this away from the origin, so if it's not sitting at the origin, that means there's a horizontal shift, or if we move it up or down, there's a vertical shift. Now when we make those changes, just like we have used h and k in the past, you'll notice that this right here becomes the equation, where x is moving that x value, h is moving the x value left or right. And notice it's inside parentheses being squared. Anytime that happened, right, we always use the opposite of that. But again, this is moving it left or right. And then just like we always used k for the up or down, notice that that one is affecting the y value, so it's moving it up or down. So that just moves the center around the graph. R squared will stay the same, it's still hanging out over there, so we could find the radius. So remember that negative h, this means opposite. So if I want to find the x value of the center, then I use the opposite of that h value. So again, this is the x value of the center of the circle that's being represented in that equation, and the k is the y value because it moved away from the origin. So, for example, if we look down here, given the standard form of a circle, determine the center and the radius of the circle. So looking at this guy up here, again, remember it's like x minus h, y minus k, and then this guy is r squared. So our center in this case would be a positive 2 because we do the opposite of h, and a positive 3. So this guy, the center moved to the right 2, then it moved up 3, so the center would be at the point 2, 3. And the radius, if r squared is 16, then the square root of 16 must be 4, right? 4 squared would give me that 16. So we can find the center and radius. Then it's a matter of just doing that over and over, looking through this. So again, here's my h, here's my k, here's my r squared. So h again is at 1. I do the opposite of positive 7, which is negative 7. So this guy moved in the negative direction going down. And then the radius, so if we take 25, the square root of 25, right, is 5. Okay, let's graph a couple of these. So first of all, to graph it, you need to identify your center and radius. Those are the two things that you need. Just like when you graph a line, you need the y-intercept and the slope or something like that. On this one, you need the center and the radius. So notice up here, this time our radius is over here, but if that's r squared, the square root of 4 is 2. So I know that my radius is going to be equal to 2. My center is going to be the opposite here, so negative 3. And then notice nothing is added or subtracted to the y value. That means it didn't move anywhere in the y direction, so we're at 0. So if I want to graph this, I come over to my graph, and I go to the negative 3, 0. That's the first point I'm going to put there. And remember we labeled circles by their center. That's how we named them. So because this one's part A, I'm going to call this circle A. So I'm going to label that center A so that I can distinguish the circles. And then the radius length here is 2. So you're going to go 2 in each direction. Now diagonal directions are a little bit harder to draw exact lengths. So we're just going to go 2 in the right direction, 2 units to the left of our center, 2 units down, and 2 units up, and then you're going to do the very best you can to draw a circle. And they are very tricky, but again, best you can. That's the circle there. That would be circle A. All right, let's try it again with B. Again, we find our center, so we look up here to the opposite of that for our x value. The opposite of negative 4 is positive 4, and this is r squared. The square root of 1 is actually 1. So again, I'm going to go to the left 2. I'm going to go up 1, 2, 3, 4, and that's where I'm going to put my center. And again, this one's part B, so I'm going to call that circle B. And the radius is only 1, so you're going to go 1 unit in each direction to graph this. I think it would make drawing the circle easier, but yikes. Okay, there's circle B. Alright, lastly, I'll quickly draw this one. So again, the center, if the x doesn't move anywhere, that's 0. This one moved 2 in the right direction. And then our radius, now that one seems a little bit tricky, but the square root of 14 is essentially what you're looking for there. And if you want to approximate that, because that's a little bit weird, that would be about 1.9. So we would come over, we would go 0, 2, which is here. 1.9 is just under 2, right? So I'm going about 2 units in each direction. And then, oh dear, this, it's getting worse. So let's try that again. Okay. Well, there you have it. All right. I'm going to do 2 more of these and then I will stop for the next video. Hopefully we can kind of see going the other direction. So now we're given the graph and we're going to build the equation. So again, in order to build the equation, you need the same items. So my center on this one is at 0, 0. So that's really important. We know that. And then the radius we count. So this is 2 units away, 4 units away. If you look at the radius of the circle in any direction, it looks like it's 4 units. So we're looking at a radius of 4. When we build our equation, again, I'm just going to write it out so we remember what it is. We do x minus whatever that value is, and in this case it's 0, plus y minus whatever that value is, which again is 0, equals r squared. So we could write it like that. That's not an incorrect form. Simplified would be x squared, because we don't need to write in the 0, plus y squared is equal to, and then we square that 4, so 4 times 4 is 16. So this would kind of be our final equation. Now again, if you leave it in this form, I'm okay with that. That's just fine. Number 4, looking at this one, again, you have a center. If you look at your radius here, if you were to count those are going by ones, so 1, 2, 3. So here my center is at negative 2 and it's up 2. And the radius is 3 units long. So again, we build our equation. We do x and the opposite when we put it in here. So if that's negative 2, I'm going to put plus 2. Y minus 2, because this guy up here is a positive 2. and don't forget to put squareds on those, is equal to 3 squared, right? So 3 squared is 9. Okay, that's the basic of building a circle equation and graphing a circle. In the next video, we'll talk a little bit more how to do that algebraically when you're given different parts.